All right, everybody. So we are going to go over 4 skills in this one video. So it'll be slightly longer, and I'm sorry it's getting uploaded later, but it is what it is. It's still getting to you before your exam tomorrow. So in the latter half of the Unit 5 unit, we were talking about gas laws. And so the first one we learned about was Boyle's law, which explains the relationship between pressure and volume. So one thing to remind ourselves is, okay, well, what is pressure? What is volume? And so pressure inside a container is a force that's created when the molecules of a gas collide with the walls of your container. So imagine a balloon, the gas molecules are bouncing around in there and they keep hitting the balloon, and that's what makes them like push back on yourself. So if you're pushing in on a balloon, it almost feels like something is pushing back. It's the gas molecules. And so pressure is measured with the unit atmospheres. So if you see the abbreviation ATM, that is not at the moment. It's not the place where you go get cash. It's atmospheres. And volume is a measure of the space or amount, of the, what was supposed to go there? This is the amount of space. Volume is measure of the, I don't remember what's supposed to go in that blank, but it's the amount of space a gas takes up and is measured with the unit liters. I feel like that blank is going to come up to me later, but I'm too tired, so who knows. According to Boyle's law, when the pressure is increased, the volume will increase. The volume will decrease. Okay, and when the pressure is decreased, the volume will increase. So they have an indirect relationship. So when pressure goes up, the volume goes down. Imagine, if you will, that you have a balloon and you start pushing on it. Okay, you're going to make the balloon smaller, eventually to the point where it has to pop. So the formula for this relationship for Boyle's law is P1 times V1 is equal to P2 times V2. And so the ones and the twos, your 1 would be your initial pressure and volume, your 2s are your final pressure and volume. And so the key thing to remember is that when we look at a problem, so for example, question 1 says the volume of a gas at 2.6 atmospheres is 17 liters. So what we see here is these two numbers are connected by this word is. They are being measured at the same time. So that means they're either both our 1s or they're both the 2s. They go together. So I've got a pressure and I've got a volume. I know that this is pressure because of atmospheres, and I know that this is volume because of liters. Because they're connected together, I'm going to make them both my 1s. It says the pressure is increased to 6.7 atm. So we have another pressure because of atmospheres. It's after it's been increased, so we know it's the change, so it's P2. And it says, what will be the new volume? So that means they want to know, okay, what is V2? What will be the new volume? Now, we already know that when pressure goes up, the volume has to go down. So because my pressure has increased from 2.6 to 6.7, my new volume should be smaller than my first volume. But we write down our formula. So we have P1 times V1 equals P2 times V2. Now, the thing to remember is that if I'm solving for V2, that means I want to have that by itself. So P2 has to get moved over here. Well, to do that, you do the opposite of the math. So we would divide by P2 on both sides. That cancels out. So we know that V2 is equal to P1 times V1 divided by P2. So we just plug in our numbers. P1 is 2.6 atmospheres. V1 oops, let me draw my multiplication sign. V1 is 17.0 liters, and my P2 is 6.7 atmospheres. Now, so many of you forget to actually include your unit with your number, but it's important because we see here that atmospheres is going to cancel out, and we're going to be left with just liters, which is good because I'm trying to find volume. So that is what it should be. And so what we'll do is we're going to multiply the two numbers at the top first. So 2.6 times 17.0, and that gives us 44.2. And then we divide by 6.7. And so that will give us 6.6 liters. So we can see it did indeed go down. So our volume decreased from 17.0 liters to 6.6 liters. And that is what V2 is equal to. So what I want you to do is I want you to pause the video and try question number 2 on your own and press play, and you'll be able to see the answer and check your work. Okay, so now that you've pressed play and worked it out to check your answer, you can see that you should have gotten 32.7 atmospheres. If that's not what you got, then go ahead and check your work. Make sure that you labeled everything correctly using your units and that you plugged it into your formula. If you plugged it into your formula and labeled everything correctly and you still don't have the answer, then I recommend checking your calculator and plugging it in. Make sure you multiply these first and then divide by 1.1. Now, the second law that we learned for gas laws was about Charles' law, which tells us the relationship between volume and temperature. So temperature measures the average kinetic energy, or the speed of the gas molecules. So we know that temperature is measured with the unit of Celsius, degrees Celsius. However, because of the relationship between volume and temperature, scientists created a unit of temperature called Kelvin. It's named after the guy who did it. And the key thing is that Kelvin has no negative numbers. So with Fahrenheit and with Celsius, you can have, -8 degrees Celsius, -32 degrees Fahrenheit. They all have negatives. Kelvin doesn't. It starts at 0 and it can only get higher than that. So according to Charles' law, when the temperature is increased, then the volume will also increase. And when the temperature is decreased, the volume will also decrease. Think about it this way. If the molecules are moving really fast, then they hit the balloon with a larger force, so it expands the balloon, the volume increases. Now, the formula for this relationship is, let's see, where do I want to write that? I'll write it here, is V1 times T2 is equal to V2 times T1. Notice that my 1's are on opposite sides and my 2's are on opposite sides of the equal sign. The key thing about this formula, though, is that all temperature values must be in Kelvin, not in Celsius. Otherwise, it doesn't work. Now, the formula to change Celsius into Kelvin is that Kelvin is equal to whatever you have in degrees Celsius plus 273. And the reverse, if you have Kelvin, but you want to change your answer into Celsius, your degrees Celsius would be equal to whatever you have in Kelvin minus 273. I have another spot to write the formula. That's silly. So again, we have V1 times T2 equals V2 times T1. Key thing is that it is in Kelvin. So when we look at question 1, it says, what is the temperature of the gas? Okay, so we know that we are looking for a temperature. We don't know which one, but we know that it has a volume of 4.5 liters. Okay, so if I go ahead and just say that's V1, then this automatically has to be T1. Oh, But let's keep reading because that might have been a mistake. It says the gas had an initial temperature of 45 degrees Celsius. Well, since that says initial, we're actually going to label that one T1, which makes this T2. And it says the volume was 2.7. So that must be our V1, and this is V2. Now, it doesn't really matter if I make, the 4.5 and my unknown, the 2's, and the 45 and the 2.7, my 1's. As long as this number and that number both are 1's or 2's, and that this number and our unknown have the same, then your formula will work out even if you swap, and say that 4.5 is V1 and 2.7 is V2. As long as the temperatures are also swapped. So you know which numbers go together. So we know that as soon as we see a temperature here, okay, you should be adding it into Kelvin. So 45 degrees plus 273 gives us something that, since I did my math wrong last time, I'm just going to use my calculator because it's a safer bet. 318 Kelvin. Now make sure you use your units there. Write them down. So if we want T2, our formula, V1 times T2 equals V2 times T1. If we're trying to find T2, that means we will need to move V1 to the other side by dividing, because that's the opposite of multiply. So that cancels out. And T2 is equal to V2 times T1 divided by V1. So just plug in my numbers. V2 is 4.5 liters times T1. Now remember, T1 is not the 45 degrees Celsius. To put it in this formula, we have to use the 318 Kelvin. And then we divide by V1, which is 2.7 liters. We'll notice that liters cancels out. And so again, we do this in our calculator. We simplify the numerator first. So 4.5 times 318 is 1,431. And then we divide by 2.7. And that gives us 530 Kelvin, because that is my unit. Now, this question just says, what is the temperature? So we can leave it in this unit, okay? If it said, what is the temperature of the gas in Celsius, then we would need to say, okay, minus 273 is 257 degrees Celsius. So pay attention. If it says in Celsius, then you would have to do this last step. But since it doesn't, we can leave it in 530 Kelvin. Now, what I want you to do is, again, pause the video and actually literally pause the video, okay? Practice is how you get better at this. Okay, pause the video, try question 2, and then press play and wait a few seconds, and the answer will show up. Okay, so now that you've worked out that problem, you can see your work here. Make sure that you've rearranged your formula correctly. You've shown all your work, including how you change your temperatures into Kelvin, because that is one of the skills in your gradebook, and that you've plugged your formula or your numbers into your formula correctly. And that you should have liters for your final unit, because they were asking for volume, and volume is measured in liters. So the next video will go through the remaining 2 gas laws, and we'll wrap up with a summarizing chart that will be helpful for you as you take your exam.